All right, so we're going to prove the change of base property for logarithms, which states that for any logarithmic bases a and b and any positive number m, we have log base b of m is equal to log base a of m over log base a of b. So notice we changed the base from b to a using this formula, right? All right, so let's go ahead and start the proof. So we're going to let y be equal to log base b of m. Well, using the definition of logarithms, we know this is the same thing as b to the y is equal to m. And then using what we can do is we can take log base a of both sides to get log base a of b to the y is equal to log base a of m. Next, we can use the power rule to move this y from this exponent spot here to in front of log base a being multiplied by it. So using the power rule, we can do y log base a of b is equal to log base a of m. Now I have y is equal to log base b of m, and if I can convince myself to divide both sides of this by log base a of b, then I have y is equal to log base a of m over log base a of b, and y is equal to log base b of m, and that's exactly what I want to show, right? I have that log base b of m would be equal to log base b of a over log base a of b. So I have to convince myself that I can divide both sides by log base a of b. So I'm going to have let x be equal to log base a of b. So this is the same thing as saying a to the x is equal to b. Now, since a and b are both bases, I know a property of bases. I know that a cannot be equal to 1 and b cannot be equal to 1. So this means that x can never be 0, right? Because some power raised to the 0 gives me 1, right? But b can't be 1 because it's a base. So in any situation, this x can never be 0. So if x can't be 0, that means log base a of b can never be 0. And that means I can actually divide both sides of this by log base a of b, right? So this tells me, right, that x cannot be 0, or log base a of b cannot be 0. So now I know I can divide both sides of this equation. So I'm going to go down here. So this was a little side, right? A little side tour. So back to the proof, I now know that I can divide both sides by log base a of b. So I get y is equal to log base a of m over log base a of b. And now I have log base b of m is equal to y, and y is equal to log base a of m over log base a of b. So of course this means, right, that log base b of m is equal to log base a of m over log base a of b. And that is the change of bases property for logarithms. That is the proof.